Alrighty. Recording has started. That means tutorial has started. Everybody, welcome to the morning tutorial class. This is part of the trial week or two that Nick is doing to see how many people like the 3 different tutorial times as opposed to all 3 tutorials at the same time. Considering nobody has showed up, that's a horrible sign. This morning slot may not be continuing. So we will see. Um, that being said, because nobody is here, I don't have to actually treat this as if it's an interactive video. I can treat this as if it's a proper recording. So that's what I'm going to do. So, welcome to the recording on Recursion. So, what is Recursion? Well, Recursion is basically just a loop. It's a loop in which it references itself. That's how it loops. It doesn't have a specific loop construct. It just calls itself as a function. I have quite a few questions to help really dig in what makes recursion, and I've organized them into this follow along type notebook. It's honestly quite helpful. There's the warm-up section, then the proper tutorial questions. So we're going to start with your basic recursive definition for a warm-up. And we actually have one person who wants to join a morning recording. Welcome, Benjamin. Anyways, yeah, so this is the morning tutorial, as Nick posted. Don't know how many people are going to show up. We'll find out. I'm just going to continue on. You haven't missed anything. We haven't started. So, yeah. So recursion. What is recursion? Well, you can see from the mathematical definition that we have here, recursion is the idea of a function referencing itself to continue until you hit some sort of base case. Factorial is the easiest one to really talk about. You have factorial of n. It's so early. So yeah, the tutorials are being split into 3 times. You are meant to go to the time you feel comfortable attending. So there's one the hour before class, there's one immediately after class, and then there's one later in the evening. So you can attend whatever tutorial you find the most convenient to attend. The notion of a tutorial being bound to a specific person, we're throwing that out. So if you don't want to be here, you don't have to be here. I'm just gonna continue on. I'd just be sleeping right now, so I'd rather just go now. Yeah, that's a smart idea. Anyways, so factorial, if it's lesser than or equal to 1, it returns the number 1. Else, it takes that n and multiplies it by whatever value is factorial of n minus 1. You guys should have all seen this by now. It's not hard. If n less than or equal to 1, return 1. Else, we return n times factorial n. Notice how both of these cases point to the equal sign. This bracket always points to this one equal sign. You must have a return for every case because the return isn't universal. Here we have one return and then the bracket points them all to the return. That's not the case in code. If you're going to type return 1 for this guy because he points to the bracket, which points to the equals, whoops, then you're also going to have to do return n times factorial of n minus 1 because he also points to the bracket, which points to the equal sign. You always have returns. I have a test case here for us to run the code. And notice how nothing's happening. Well, I didn't type n minus 1. That's all it is. Oops. So now I've got to kill the code cells, which means that that's an infinite loop because I have infinite recursion. So I'm just going to kill the notebook, start it back up, run this cell so that way I don't hit infinite recursion again, and now it works. So yeah, you have to make sure that your recursive case always heads towards your base case. Factorial of n minus 1 continuously or decrements n, so eventually, as long as it's an integer, I get to this case here. I don't want infinity, no matter what I do. Um, Another example, another quick warm up, is one that we did from our earlier tutorial, the greatest common denominator. Now, this is the Euclidean method, which we did a loop for. However, it can also be written recursively. In fact, originally speaking, it was written recursively. So if b is equivalent to 0, then we just return a. However, if b isn't 0, the otherwise case, we simply return the GCD. We swap b into this spot here and do a mod b as what b is. If you go back to the loop equivalent, you will see it's very much the exact same code. It's the exact same idea anyways. And as you can see, the greatest common denominator between 12 and 48 is still 12. This, again, it's another warm-up one. You guys, if you're presented a mathematical formula exactly like this, there should be no challenge in turning it into recursion, because literally everything's just set up for you. Here's your if statement, here's your return, here's the function name. Boom. The issue is, on assignments, you will be given questions that contain no formulas. You will be given an English description. So let's take a look at a simple recursive sort. The recursive sort will pop out the minimum element and put it at the front of a new list. So what we have to do then is first identify a base case, and then identify a recursive case, because eventually the list has to keep ending. And what I'm going to do is I'm going to actually print the list. And I'm going to print the list so that way we can watch what happens as it recurses. So what is my base case? Well, what is the base case of a list? Remember, a list is a data structure. If the list is empty, or the length of the list is only 1, so what I can abbreviate this to is if the length of the list is less than or equal to 1, because those are the same case. Well, in that case, I'm just going to return the list. The list is either empty, in which case there's nothing to sort, or has one element, in which case is the minimum element of that list. The recursive case is where it gets a bit more interesting, because I have to find some sort of minimum. And of course, we all know the correct way to do that is just called min, because we're lazy. Then I have to ask L to remove said minimum, and then I have to make a new list containing the minimum and append the recursion of simple recursive sort. I just realized I screwed up there. So I find the minimum element, remove the minimum element from the list, and count the recursive, or I just recurse. The count part, however, is due to a quick issue regarding this. ls.remove. How many times does .remove remove the same element? I don't know. Oh, someone just unmuted. So let's say I have the following list: 1, 1, 1, 1, 1. If you guys don't know what test is, it's in the notebook. It's just a simple testing function I made. So what happens when I do 1, 1, 1, 1? Luckily, it only removes 1, 1 at a time. So you know what? That's good. I don't have to worry about this case. This is an example of a case we would not give you on a test, but you have to test yourself. If you see a sorting algorithm And potentially speaking, you don't know what happens if you give the same element 5 times. Well, it should be the element 5 times, element 4 times, element 3 times, element 2 times, element 1 time, and then your sorted list should still contain all 5 elements. So if I use my test function, which would make a random list and sort it, randint is not defined. You guys will have to make this change if you want to use my test. From random import rand int. I knew I forgot something, but I was like, no, this will work fine. So if I run the test case again, here's the random list it generated. And you can see step by step, it goes through and finds the minimum element, which is 1, removes it. Goes through and finds the minimum element, which is 10, removes it. Goes through, finds the minimum element, which is 58, removes one of the 69s, removes the second 69, removes one of the 79s, removes the second 79, remove the 90, remove the 92, remove the 99, and I have a sorted list. Now, this is a lot of calls because this is one call per element. We want something relatively smaller, and I will tell you there is something relatively smaller, and we're going to look at it at the end of tutorial. However, I have to do another warm-up question because it's one of the mandated questions. The Pascal's triangle or binomial expansion. Binomial expansion is a term that even I did not recognize at first. Now, remember, taking grade 12 calculus is a prerequisite of this course, so it is expected that you know everything about Pascal's triangle and binomial expansion. But that's not to say that we're assholes and we won't give you a quick description. So Pascal's triangle, or binomial expansion as you might know it, is a triangle where you would pass in a plus b to the exponent of n, and it's the series of coefficients for each item. So if I did a plus b to the power of 0, which is this level, I should get the number 1 back. It's a constant. There's no multiplication. If I do a plus b to the power of 1, I do 1 times a plus 1 times b. That's nice and simple. A plus b to the power of 2 is 1 times a plus 2 times ab times 1 times b, or 1 times b squared, sorry. So 1 times a squared, 2 times ab, 1 times b squared. This one is a plus b to the power of 3, which is 1 times a cubed plus 3 times a squared b plus 3 times ab squared plus 3b squared, or b cubed, etc., etc. You don't necessarily need to know that part because this question only wants you to generate the triangle. Now, what is the triangle? Let's ignore binomial expansion and ignore all of the calculus and just ask what makes the triangle. Well, there's a couple properties about a triangle. One, if the exponent is 0, you return a list just containing the number 1. That's your base case. If it's not 0, you return a list of elements that will begin with the number 1, end with the number 1, and every item in the middle is the sum of the 2 items directly above it in the triangle. Now, the way I have it illustrated here isn't helpful. So if I Google a Pascal's triangle image, it's much easier to see using an image like this. Can I open the image in a new tab? Yes, I can. So Pascal's triangle is much easier to look when it actually looks like a pyramid. Because if you think about it, you have 1, 1, 1. These are 2 base cases that don't follow the rule. Then 1 on the end. 2 is the sum of 1 plus 1, 1 on the end. 1 on the end. 3 is the sum of 1 plus 2. 3 is the sum of 2 plus 1, 1 on the end. 1 on the end, 4 is the sum of 1 plus 3. 6 is the sum of 3 plus 3. 4 is the sum of 3 plus 1, 1 on the end. 1 on the end, 5 is the sum of 1 plus 5, 10 is the sum of 4 plus 6, 10 is the sum of 6 plus 4, 4 is the sum of, 5 is the sum of 4 plus 1, 1 on the end, etc., etc. So that's how you're meant to look at a Pascal's triangle, which means we've identified our base case and our recursion case. Base case, exponent is 0, return only 1. Else, what you're going to do is return the 1 and 1, and in the middle, the sum of all of the values. That's your recursion case. I know it's a little iffy to understand, but if you know about Pascal's triangle coming into this, it's a lot easier to understand what I just said. Pascal's triangle is one of those things where honestly I could dedicate a full 30 minutes just talking about Pascal's triangle. Sadly, I don't have that time, mainly because you guys do have a lecture immediately after this, so I'd prefer not to waste all of your time. So, let's think. Base case. Base case, when exponent is 0, you just return 1. This is the easiest one. If exponent is 0, return a list containing only the number 1. One thing I'm going to do is I'm going to also print 1. The reason I'm going to print it is because I want to actually build the entire triangle so you guys can see that. The else case is a bit cooler because there's a bit of lineup, or there's a bit of pre-calculation. First, I need the previous line. In order to get the sum 6, I need to know that the previous line contained 3 and 3. I have to do 3 plus 3 in order to make 6. So I know that I need the previous line, and the previous line is going to be the recursion of Pascal's triangle, where you pass in exponent minus 1. I'm also going to need some sort of current line. My current line consists of only the number 1. Remember, there's a 1 on the left end, a 1 on the right end, and then a bunch of garbage in the middle. We don't know what that garbage in the middle is, but we know that line initially consists of a 1 on the left, and after you add everything, line will then consist of a 1 on the right. There's something here in the middle, but we don't know what that is. Well, I know what that is, but you guys probably haven't figured it out yet. So I have completed the base case. I have prepared for the recursion case. I just need to implement this addition rule. So I'm going to start from exponent minus 1, or I'm going to start from 0 and go to not the end because I don't care about this 1, but I'm going to go to this item here. So if you think about it, I want to stop after I've solved the answer for this 4. And the 4 would be 3 plus 1. The list above is missing one item from here. So I need to subtract 1 so that way I don't get an out of bounds error. Because this 1 that is in my current list, if I'm looking at this line, doesn't exist in the previous list. This list is too short. It is exactly 1 shorter than this list. So that's why I'm doing exponent minus 1. I am ignoring where this 1 occurs in my current line on the previous line. Then what I'm going to do is I'm going to keep doing line.append, and I'm going to take my previous line at index I, and I'm going to add it to my previous line at index I plus 1. What this will do is it goes, okay, I'm solving this line, so I'm going to start here. 1 plus 3 is 4, append that to my list. 3 plus 3 is 6, append that to my list. 3 plus 1 is 4, append that to my list. And I've finished the loop. Remember, the 1 at the beginning and the 1 at the end are both already handled. That's what these two lines are for. 1 at the beginning, 1 at the end. This line here are the middle bits. And then all I do is return my current line. And like I said, I want to print it as well so you guys can see how that looks. This is a very complex question to work out logically, but it's not outside of the realm of what we could ask you on a test. We very much could ask you this question on a test. If I build a Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, and then of course it prints 1, 5, 10, 10, 5, 1 again because that's what this returns. So it did all of the prints and then printed what it returned. That question is confusing, but just think about the code. It will make sense if you tried like tracing out what this did by hand. I think that's the more logical way to go about it. But if you really are having struggles, maybe reach out to one of your TAs, ask if they could go over the question again, maybe a bit more slowly. I've got one final question before we end for today, and then I'll let you guys get ready for your lesson with Nick. I have 20 minutes, so I have 30 minutes. We'll go over this a bit slower. So let's talk about merge sort. And merge sort, there are things on the internet that explain it much better than I can. Merge sort GIF. So merge sort, is this a GIF or it is a GIF? Merge sort is the concept of taking a list of items, breaking it into the individual pieces, as you can see in this GIF, and then taking those pieces and reorganizing them back into the correct order. You do it in blocks though. So if you're looking 7 and 8, well, 7 is smaller than 8, so it goes first. 2 goes first because it's smaller than 4, etc., etc. Now those blocks are sorted, and you look at those blocks and begin sorting again. So I'm just going to let this GIF finish playing, and then I'll re-explain just real quickly because I have the time. But you can see based off this GIF kind of the logic. Do compare, bring item down. 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 Do compare, bring item down, etc., etc. So yeah, what we need to do is starting with a list, find the halfway mark. That's why I have inserted this pipe here. Then at the halfway mark, split into 2 more lists. Repeat. Find the halfway mark, split the list into 2 more lists. Find the halfway mark, split the list into 2 more lists. Now, I still have more than 1 item per list, so find the halfway mark, split the item. Now everything is an individual item. I begin merging exactly how that GIF showed you. 4 and 7, 4 goes first, 7 goes after. 10 stays on its own because technically it's a different part of the question. 2 and 5, 2 goes first, 5 goes next, 3 stays on its own. Then looking at this line, you have 4 and 10, well 4 goes first obviously, go back up. 7 and 10, 7 goes first. This list would then be empty, so then you only have 10, put 10 in the list. Very similar here, you have 2 versus 3, 2 goes first. 2 is removed from the list, and you have 5 versus 3. Well, now 3 is smaller, so 3 goes in. Then 5 goes in because it's the last item. That's the general idea of merge sort. And the merge sort part is easiest. The breaking the list into its parts, that's the easy part. None of you should struggle with that. The hard part is merging the lists back together. So I have actually broken it down into or the merge sort breaking part and the merge function, because they're two different parts of the same question. One's a little bit easier than the other. So the merge sort part is what is recursive, which means this is going to have some sort of base case. I've used capital L here for my list name. So if the length of capital L is lesser than or equivalent to 1, that means I have a list of one item. It can't be broken. It isn't sortable. So I just return that list. Whatever that L is, I'm just going to return it because there's nothing I can do to it. Moving on from here, we're going to need a quick reminder of integer division. So if you guys remember, a/b is the exact same, strictly equivalent to math.floor a over b. This will return an integer. And integers are really good because there is no index 3.5 in a list. You're either index 3 or index 4. You have no 0.5 in a list. So let's build sublist 1 and sublist 2. And of course, you guys should already be here before I am. How do we build a sublist? We use string slicing or array slicing or whatever you want to call it. Slicing, because that's technically what it's called. But hey, doesn't matter. We're going to use slicing. Slicing involves a start and an end position with going up by an increment value. The increment value, of course, is going to be 1 because we want every item to be in the subarray. When I look at 4, 7, 10, 2, 5, 1, I don't want to skip the 7 when I'm breaking into two lists. Second, where do I start? Well, I'm always starting at the beginning, and the sublist 2 is always ending at the end. It's this part right here, where that pipe is, the division point. So I'm going to create another variable called division point. And what is division point equivalent to? Well, if we know the length of the list is length of L, and I want to split it in half, I want to do length of L divided by 2. Now I would go from 0, which remember is assumed by default, so you don't have to type anything here, to the division point. And then my sublist 2, I want to start at the division point and go to the length of L minus 1, which again, remember, it's assumed. I don't need to type anything here because my starting point is assumed for me, and I don't have to type anything here because my endpoint is assumed for me. So the sublists are now exactly what I want. Now I need to know, what do I return? I've broken the list into two parts. I now need to recurse and merge. And that's the hard part because I'm going to be calling another function, and the arguments I'm passing into that other function are going to be my recursively sorted lists. I'm going to call merge sort on each of the lists I pass into merge. Now, a lot of you will be like, wow, we can do that? And it's like, yes, because Python very much builds everything as a instruction tree. So when the Python sees return, merge sort sublist 1, merge sort sublist 2, Python will go, okay, what do I need to solve merge? Well, I need merge sort sublist 1. So I'm going to solve merge sort sublist 1. Then I need merge sort sublist 2. I'm going to solve merge sort sublist 2. Then once I'm done those, I'll come back up to merge and merge them afterwards. So what this is going to do is exactly what we've depicted here. It's going to start with the big list, break into smaller list, break into smaller list again because it has to, break into smaller list, then it found its smallest list. It has nothing to merge sort anymore, meaning that it's going to then combine the two smallest lists. So that way it can then combine the two medium sized lists. So that way it can then combine the one big list. It's kind of wonky, but it makes a bit of sense, or I hope it makes a bit of sense. Finally, we code merge. Merge is far too annoying to make recursive. It is way too annoying to make recursive. Like, you guys wouldn't be expected to do it because nobody in their right mind would want to do it. So, how do we make merge? Well, it's really easy. Make a list. Make some sort of list. You're going to put all of your values into this list. At the end, you are going to return said list. So it's very important that you have a list. Then we're going to have a while loop. And the reason we're going to have a while loop is because we are not doing anything to do with the index in a loop. What I'm going to do is I'm going to have this while loop detect if the lists are empty. So the way you detect if a list is empty is if the length of both lists, when added together, are greater than 0. Because if the two lists are empty, that should be equal to 0. There's nothing in either list, so you're done. The moment you are still dealing with X being 1 or Y being 1 or something, the moment either of them have a length to them, you can't end this loop. You still have items you need to sort. Next, we implement the sorting logic. The sorting logic is quite simple. If the length of X is equivalent to 0, this means there is nothing in my left list. You can imagine it if I passed this to merge, an empty list and 10. Well, what gets put in the sorted list? Obviously 10. There's nothing in the left list to sort. So if the length of X is equivalent to 0, my answer is really just answer plus equals Y. It's everything in Y gets put in answer. Now, this doesn't quite work because the loop doesn't break. I would need to manually break my while loop to tell it that if Y contains 7 items, put all 7 items, assuming they're sorted, into my answer list, and then break this while loop because I have finished. Very similarly, there's another condition almost exactly to what we have just done, but it's assuming the right list is empty. So in this case, if I had 10 was empty, and you go, well, is 4 bigger than, well, wait, there's nothing to compare it to. So I can take 4 and I can put it in my list. And then I look at 7 and I go, is 7 big? Wait, there's still nothing to compare it to. So I can just take 7 and put it in my list. This is why I'm adding the entirety of the list. No matter how many elements are here, there's nothing to compare them to ever in the right list. Meaning that I have to take all of these elements in the left list, no matter how many there are, and put them in my sorted list, my answer list, if you so would. So those are the two easiest cases. There are 2 more cases now. The cases where both lists contain some quantity of elements. I don't know how many, but I know they both contain something. So they both clearly have a head because they have some sort of length. And what I care about is the item in X smaller than the item in Y? Is 4 less than 10? Is 2 less than 5? You know, stuff like that. If this is true, I'm going to append the smaller item, x0, and then I'm going to do x equals x1 onwards. What this does is it pops the first item from list X out of list X. My throat's a little hoarse for a moment, so I'm just going to take a drink and we'll resume once I've had a quick sustenance break. But just let that sink in. Alrighty. So, anyways, yeah. If the item at the head of X is smaller than the item at the head of Y, put the head of X into the sorted list and pop the head of X out of X. We've now dealt with it. It is done. Very similarly, the final case, either the head of Y is greater than X or the head of Y is equivalent to the head of X. Either way, it would be handled by an else statement. And it is exactly what we had before. However, instead of X, everything is now Y. These are the only 4 cases. If left list is empty, put the right list in the sorted list. If the right list is empty, put the left list in the sorted list. If the item in the left list is smaller than the item in the right list, put it in the sorted list and remove it. Else, put the item in the right list and remove that. It is a long question. It is a pretty mentally demanding question. I don't think it's harder than Pascal's triangle, but I still think it's a hard question. However, if I take a look, list before sorting, 90, 9, 12, 72, 0, 2, 5, 7, 9, 7, 52, blah, blah, blah. 0, 2, 9, 12, 52, 57, 72, 90, 91, 97. You can see it sorts the lists. You can also see, I don't know if I have tests specifically determine. No, I don't have any print statements. Let's put a print statement so you guys can see exactly what is happening. Because I think it's cool to see what's happening. I'm going to remove the chonky list. Here we go. So this was the list before sorting. Then that list, analyzed whole, is split in half. We have the first half, looks here. And then we split that in half. Then we split that in half. And we get one item, the left item. And we have the right item. Then we look at the other half, split that in half and that in half. Then that in half and that in half. Now, I can't show you the merge, but you can assume that these lists, 49 and 36, were then merged in the correct order. And then once 90, 80, and 84 were merged in the correct order, those were then merged. Then we look at the right hand, that gets split, that gets split, and that gets split. This guy gets split, and then this guy gets split, and then those all get merged back into one final list. I wonder if I can show you guys. What happens if I do print answer? Do you think this will show the merge step? It does show the merge step. Awesome. So splits in half, splits in half, splits in half, base case. Merge the base case. Cool. Splits in half, that's one base case. Splits this in half, there's another base case. Merge that base case, then merge that base case with the previously found base case. Cool. Merge those two base cases, And now we've sorted the left hand of the entire list. This has happened just automatically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Boom. We have already sorted half the list. Now, I know it looks as if this takes longer than the simple recursive sort, because remember, this only printed 10 items or 20 items, depending on the size of the list. What you guys need to remember, though, is sorting this left list and sorting this right list are happening at the exact same time. Python is not doing one first, then the other. These are happening side by side with each other because they're unrelated operations. So actually, to sort this list of 6 items, we have broken it once, twice, three times, merged once, twice, 3 times. We did 6 items. So if you think about it, this step and this step here are happening side by side. This is why this algorithm is preferred, because it's what we call a log n algorithm. It is a algorithm that does not necessarily take n items, but on average it actually takes the log of base 2 of those items. So if I pass in 10 items, it would actually only run roughly like 4 times. It's actually closer to 3 point blah 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 blah, but you can't have decimals. So this is why this algorithm is loved so much more. It's just looking at the code, it doesn't look like it. Because when you see this, this is a lot of lines. This is a butt ton of lines. But you need to remember is the lines are happening in parallel with each other. This step here is happening at the same time this step here has happened, and then this step here and this step here happened at the same time, which is why you got here. It's incredibly hard to show because everything is printed in a straight line. But there is not this many instructions happening linearly. They're happening at the same time, and Python just has to pick an order to print them. Okay. That was a lot. I know that was a lot. That was a butt ton to cover. But that is all I have for today. Now, there are only 2 of you here, and you probably are like, whoa. Because, yeah, these were a lot to cover. These are very much things that you're expected to go on YouTube, watch a quick video that better explains the theory behind the algorithms. These are just looking at the code. And there are courses, and I kid you not, courses plural, dedicated to the theory behind stuff like merge sorts, or there's a quick sort, heap sort. So many different sorting algorithms, so many different recursive definitions that we just don't teach you. And sadly, I don't cover that. I have to assume that you guys will actively go out and try these and go, well, okay, so what does this line here do? Well, it splits into a sublist and splits up to a sublist. Then this happens at the same time. This happens, and then this happens at the same time. And it's like drawing this out on paper, I find is much more effective for understanding the algorithm than coding it. Because yes, the code, you get an idea of what's happening, but you can't appreciate that idea. And maybe if I have time, I might record a video that goes through merge sort on paper so you guys can genuinely see how compact it really is and why it's a better sorting algorithm than pop the minimum, put the minimum in place, sort the minimum, or sort the remainder. Anyways, you guys have a actual lecture in 15 minutes. Go, be free, have fun. Um, and yeah, I might see you guys next week. You guys might pick a different tutorial time. That's completely up to you. Can I ask a question about the bonus question of assignment 4? Assignment 4, yes. I don't know of anyone getting an extension to that assignment, so you should be okay to ask it. So go ahead. Saw the question said it can be solved in 2 lines. Does the question say that? If the question probably says that. Come on, let me in. Stop the recording.